So, hi guys, we are into the week 3 of Build Space, and I think I'm very excited for this project. So, this week I dedicated my whole week to understand the architectural diagram of RAG, that is Retrieval Augmented Generation, which is a base of our project. And we will be moving deep into it in the coming weeks, and we'll be coming out with a product. So, my product mainly deals with its main aim is to uh, provide an opportunity to the UPSC aspirants so that they can upload their study material and they can ask any relevant questions from they can give any prompt. Yes, in a similar manner we give it to ChatGPT, and they'll be getting the precise answers from the document that they have uploaded. In fact, they can get to know more about the line number and the page number where the answer is starting, because if the book is very huge, like it consists of many pages, approximately to 1200 pages, 1300 pages, and it become difficult to search for an answer. So I think in that manner it will provide an ease to the user. So going ahead with that, uh, the first thing that we are looking into it is the collection of the document. So the user will be able to upload a document, as I showed a prototype in the last week. And once the document is uploaded, then the text will be broken down into smaller chunks, because since the text is very large, so automatically our large language model is not capable enough to look into that text. So we'll break it into small chunks or sentences, and here comes the process of tokenization. So I got to, like, while researching about it, I saw a very beautiful website, Tokenizer, and this is by OpenAI platform. So here we can understand like how the words are converted in the numerical form, because the computer is not able to understand the numerical form of the text or the sentences that we are giving. So if suppose I am writing, hi, my name is Aditya, and today we are building is UPSC. So we can see that there are 15 tokens. So each token is made up of 4 characters. And if I look into the token ID, so this is actually that is being used by our system. So this is all about it, the process of tokenization. Then once it is broken down into smaller chunks, we make we try to make like the documents that we have, like based on the context that they are using, we try to merge it into the single sentence, so that it is easy for our LLM to understand it. Okay, once that is done, we convert it into embeddings. There are various embedding models, and Hugging Face is one of the best library which provides us various embedding models that can be used to convert our English text into the numerical form, because our system will not be able to understand it in the string format. So this is very important. Like, this step is very important. And once that is done, it is stored into a vector database. And suppose now user ask a question from our model, like our application, what is the Charter Act of 1853. So first, this query will also be converted into the form of embeddings in a similar way as a document is converted. So once that is done, we have a if you are able to relate, we have a embedding that is of a query form, and we have a vector database which contains a whole PDF. So we'll be performing a similarity search of a query embedding with the database, and it can be a cosine similarity, Jaccard similarity, depending upon the situation we can go ahead with that. And since we know that cosine similarity, the value is between 0 to 1, so if it is closer to 1, we'll pick that chunk out from the vector database, and we get our relevant passages. Once we get our relevant passages, then there is another option that we can go ahead with, that I got to, I asked about this project from various people, and they gave me some suggestions regarding it, that the information can also be extracted from the browser. So depending upon the need, the LLM can generate 3 kinds of output. The one can be from the relevant passages that we got. We can get a study, like we can get our answer from the study material, or the second can be a hybrid of the answer from the study material or from the information that is available on the browser, and the third it can totally depend upon the browser, so it will be working in a similar way as ChatGPT is working on. And once that is done, we'll be providing it to the web interface, and that is basically nothing but a UI or UX that has been designed by us for the front end. So this is how the brief of it. I have piled up my 1 week of the research and everything that I did into just a small diagram so that everybody is able to understand. And this is also for my track, and I hope that I come up with some good application that will have a good use case and people will be able to use it. So thank you for it and hope you like it. And if you have any suggestions, you can drop in the comment section.